Hello everyone! In this tutorial we will learn how to add physics to our game using Wade Physics. Now the first thing we need to do, as always, is navigate to www.clockworkchili.com/Wade. If we give this a sec, it will bring up the editor. I'm just going to full screen here. And I'm going to click Skip Tutorials. So we're going to create a new project. And we are just going to call this Physics. And we go ahead and create the project. Now the first thing we need to do is click on this button up here. It looks like an atom and it is physics. If you hover over and then it says this is going to add Wade Physics to your project. Okay. So that is all working nicely. We'll just quickly save there. Now the first thing we're going to do is add some ground. So click on New Scene Object. And we're just going to stretch this box out just to use it as our ground plane for our simulations. So you can just manipulate it any way you want, make it bigger, smaller. There we go. Now we need to go into behaviors on this scene object. And you'll notice physics object has already come up here. That is because we pressed the physics button before. So we click the plus. And here we have a whole range of options, but luckily for the ground we don't actually have to change anything. That will do just fine. So I'm going to add a second physics object, which is going to be the dynamic one. The ground is static, that means it does not move, it does not receive any momentum when it is collided by another object. So we just click New Scene Object, and this gives us a square. Now we are going to go to Properties, and we'll just name this object Square so we can reference it later on. And once again we go to Behaviors, Physics Objects, and we click the plus. So now both these objects have the physics object behavior. However, we need to do some work on the square. First of all, body type is set to static. We don't want that. We want the square to be dynamic. It must move, so we change this to dynamic. Okay, the gravity is set to 1. That should be okay. And for now, I'm going to leave the restitution at 1 just so you can see what it does. So we save our program and we run again. So this time we end up with a square that falls down due to gravity. It collides with the ground and it bounces straight back up. Now if I just leave my mouse cursor on the height it bounces to, you'll notice it bounces to the same height every time and it doesn't appear to be lowering in its height. It should be really losing energy with each bounce. However, we have this restitution value. When the restitution is set to 1, basically all energy is conserved. If you collide with something at a given speed, you will bounce off it at the same speed. You will not slow down. In real life, this doesn't really happen. When an object hits something, it loses some energy through various forms, sound, the object itself may flex slightly. So basically energy is lost. So if we want to make this more realistic, we'll try a value of 0.5. So I just go ahead and run that. And oh, I'm sorry, we forgot to do one other thing. The ground also has its own restitution value, and by default it will take the object with the highest value. So because the ground is 1, the physics was still taking that as 1. So now they are both 0.5. We should see a difference here. And indeed we do. That slows down quite quickly. It's a lot more realistic. Now, you set your restitution value depending on what object you've got. So if you have an anvil dropping in a game, that's probably not going to bounce very much. It's very heavy, it's not very flexible. It'll lose most of its energy. Whereas if you had a ping pong ball, for example, that maintains its energy quite well, so long as it's colliding with a hard surface. So that is very nice. Now, so far all we have done is collide a square with a rectangle, but we can also have other shapes. So I'm just going to go ahead and click New Scene Object. And here we get another square, but instead we are going to have a procedural circle. There we go. Now, like before, we go into Behaviors, and we add the physics object. Now, we need to change body type to dynamic, so of course we want this circle to move, not just be a static, boring object. It wouldn't be very fun. And in shape type, we need to change that to circle. So we'll just save and run our project. So as you can see, both fall down. The circle jumps higher because it has a higher restitution value. That's perfectly fine. We'll just go ahead and move that down to 0.5, and I'm going to move the objects around so we can see them interacting with each other. So we just save and run again. And there you go, you can see the circle is actually rolling there, it collided with the square. And you don't actually have to keep these objects aligned on their axes, we can rotate it. So I can rotate the square, I can put the circle underneath it, and we can see how that works out. Oh, it almost balanced, but not quite. And the circle rolls and rolls. And it will slow down if you add friction, but for now there isn't any, so it just rolls and it falls off the end of the world. Now, you might not want to have these objects interacting like this, or you might want to have direct control over one. So what we're going to do is we're going to allow you to manipulate the square. So what we want to do is when we click the mouse, we want the square to basically follow the mouse cursor. But when we leave go, we want it to be released and just behave as it would if it was any other physics object. So we're going to select our square, go to Functions, and go to On Mouse Down. Now we need to get the behavior first, so this.get behavior. And we are going to do add mouse joint. This is what will allow us to manipulate it using the mouse. And I'm just going to add a little flag here. This has mouse joint true. This is just so I don't try and do anything with the mouse when the joint has not yet been added. So now, if we go to app.js, this is our main program. At the moment it's fairly empty, but we're going to add two functions to this. So I'll just write the skeletons of these now for you. We are going to add wade.app on mouse up, and that is a function. And we are also going to add wade.app.on mouse, oops, not no mouse move, on mouse move. And that's also a function, but we need to pass data into this, so, oh sorry, we need to get data because we need to know the mouse coordinates. There we go. So we will do on mouse up first. So what we need to do, we need to get our scene object, and if you remember before we named the square, it is simply square, so we'll just do, oops, var object equals wade.get scene object, and then we type in the unique identifier, which is square. And we're going to need that in both of these cases, so I'm just going to go ahead and copy and paste that straight into the other one. Now, we need to have an if. This is what the flag is for. Remember, we can only do this if the mouse joint is actually active. So if we've not clicked on this object, then we don't want this to run because this is app-wide. If this happens anywhere in the app, it will become active, so we have to be a bit careful. So now we just go to object and we add our flag, which if we go back to functions here, is has mouse joint. So we can just copy that. So if we have a mouse joint, in this case on mouse up, we need to remove the joint because that's the end of our movement. So we mouse down, and if we move the mouse during that time, we want the object to move with it. But when we remove our finger from the mouse, we want it to stop, and that's what we're coding here, the code that makes this stop. So we do object.get behavior dot remove mouse joint. Oop, missed the T there. And of course we also want to set our flag to false, so just copy and paste object has mouse joint and set that to false. This is just so we don't trigger this code when there are no mouse joints on the square. Excellent. Now we're going to do something similar in this section. We're going to have if object has mouse joint once again. Now this time notice we've passed the data parameter in. Now we could get that in on mouse up as well, but we don't really need it. Here we just need it to get the screen coordinates. So I can do object.get behavior .update mouse joint, and then we pass in data.screen position. So this is the location we want the joint to be. And as a result, our square will gravitate towards that location. So let's test it out. I'm just going to save our app, and I'm going to click Run. And we see our objects fall down just as before, but if I click on the square, nothing happens. Okay, so we've clearly made a mistake here. Let's just take a look at our code. On mouse up. That looks right. And on... oh. Okay, this should be object. I was just getting a bit confused. And has mouse join is not correct, so has mouse joint. Update mouse joint. And we've got a random 0 there. I'm not sure how that got there. Interesting. Okay, so we save our app again, and we run it, and hopefully that's all that's wrong. Now, oh yes, excellent. So if I move the mouse, nothing happens, but if I left click on the square, it will move towards the cursor. And if I leave go, I can fling it, and I fling it straight out of the scene. So that is great. Now, of course, you could add this behavior to the circle as well if you wish, but for now I think the square will suffice just for a simple tutorial. I'm going to start it off rotated just so we get more interesting behavior. And I'm going to move the ball. Actually, I'm going to give the ball a higher restitution value. I want it to bounce a bit more. And we'll go with 0.9. Save. Excellent. Oh, and it's gone again. So you can have lots of fun with this. I'm just going to very quickly duplicate the ground. So I do Control D, and I'm going to do that 4 times. And then I'm just going to rotate these objects quickly. This is just for a bit of fun. You don't have to do this, it's just showing you what you can do. So it's very rough, all this overlapping. But when you duplicate the object, the behaviors get duplicated as well. So all these objects, these ground objects, will have the behavior of a static collidable object. So if I throw my box, it bounces off all the sides, and you can have lots of fun with this. You can make things fly all over the place. But anyway, that is a very brief introduction to wave physics. We will be doing more videos for physics very shortly. It's still a bit in prototype stage at the moment, so there's a lot more to add, especially with the joins. But hopefully you've enjoyed this video and you can make your own little physics app here. So thank you for watching. See you next time.